All right, chemistry, let's look at number 3. Now, number 3 is my special gift to you to really prep for college when your professors don't actually show you how to do everything, and they require that you learn from your book and not from lecture. So, there are 2 headings in the back of this section, one titled Direct Proportionality and one called Inverse, right? That is the portion of the textbook that you need to read before attempting number 3. Now, I am here to help. You can email me when you have questions. All that is good, but before I answer any of your questions, you need to do some work first, and it's going to start by reading that particular portion of the text. So here we go. The following data are given for 2 variables, A and B. And here we have our data table with our information, our data. A, in the graph provided, plot the data. So we'll start with A, 18, B, 2, A, 9, A9, and then B, 4, A, 6, B, 6, A, 3, B, 12. I'm missing one, aren't I? Hold on. 18, 9, 6, 1, 2, 3, 4. Oh, there's only 4 points. Never mind. Okay, so 4 points. So, plot the data. B, are A and B directly or inversely proportional? Now, here is how you know. In direct proportionality, there is a constant, something that needs to stay the same at all costs. Let me zoom in a little bit here. Something that needs to stay the same at all costs. It's a constant. Now, the opposite of that is inverse proportionality. Okay? Again, in inverse proportionality, it's in order to satisfy a particular constant. Now, in a direct relationship, if one of the variables change, the other variable will change in the exact same way. In inverse proportionality, if one of the variables changes, the other will change in the opposite way. And so we can look at our data table and we can ask ourselves, okay, as A changes, notice as we go from 18 to 9, we're decreasing, we're going down. As we make this change in A, what kind of change do we experience in B? Well, B is actually going up. So as A goes down, B goes up. Well, that is the inverse proportionality. So down here on B, where it says are A and B directly or inversely proportional, we just concluded that they are inversely proportional. D, do the data points form a straight line? Well, if we connect the dots here, we actually get what's called an asymptote. Hopefully you guys you remember that from math class, but no, that is not a straight line. So no. And that's actually one of the ways that you can tell inversely proportional from direct proportionality, because if this were a graph showing direct proportionality, you would see a straight line. Okay, as B would increase, so would A in the exact same way. But we don't. We see this asymptotal graph, and so no, it's not a straight line. D, which equation fits the relationship shown by the data? Is it A divided by B or A multiplied by B in order to achieve this constant? And so let's go back up to the data. When we look at each of these two data points, these sets of data points, we will either be able to multiply them or divide them and have them equal a constant. Okay, it'll always be the same thing. Well, let's try, let's try division. Okay, let's try division. 8 divided by 2, that is 9. Okay, that's 9. 9 divided by 4, okay, that's about 2.25, 2 1/4. Well, guess what? We're already off base here, because if this was going to remain constant, this should also be a 9, that should be a 9, that should be a 9. We know that's not the case, because 6 divided by 6 is 1. 3 divided by 12 is certainly less than 1. And so it's not multiplication. Sorry, not division. It must be multiplication. Let's double check this. Let's multiply 2 by 18. That's 36. Let's multiply 4 by 9. That's 36. Let's multiply 6 by 6. That is also 36. And you guessed it, 3 times 12 is 36. And so when we multiply A times B, we get a constant. We call that constant K. And so how are we going to respond to D? We're going to respond by writing A times B equals K. For E, what is the value of K? Well, what did we calculate a bunch of times up here on our data table? 36.